Hi, Trilochan Patra is the Assistant Professor of Dean Institute of Technology. Thanks the ScienceFather and Global Awards of Artificial Intelligence and Robotics for for receiving my award for my paper Resource Optimization of MIMO using Neural Network for 5G Communication. Abstract. The principal objective of this work is to optimize the resources of massive MIMO technique by an application of a neural network algorithm in order to reduce the manufacturing cost of 5G technology within the wireless peripheries of tropical regions. For plenty of annual precipitation in the tropical regions, the radio signals of these areas get attenuated in communicating any message that is signal fading occurs. Various diversity techniques have been used for diminishing signal fading in these tropical areas. MIMO technique is a special diversity technique used to minimize signal fading. MIMO technique in this paper 1 cross 1 to 256 cross 256 MIMO technique has been designed with the help of MATLAB and childing system generator, and an 8 cross 8 MIMO has been implemented in Xilinx Spintex 7 FPGA. A CMOS logic technique has been incorporated to optimize the resources of different MIMO techniques. And for this purpose, a two-layer feed-forward neural network algorithm has been adopted. A comparison of the theoretical values obtained from the design by using both Xilinx system generator and simulating with the values derived from the design by using CMOS logic gates has been displayed in this paper. For neural network optimization, three types of training algorithm has been applied. Next, I come to the introduction portion. The detection of precipitation in the tropical areas is a crucial problem which limits the transmission of millimeter wavelength signal in 5G communication. The transmission of millimeter wave signal in the tropical regions is discontinued by excessive rainfall, and the loss of signal occurs on account of the path length distribution. Rainfall increases significantly with the increase of frequency of operation, rainfall density, and working length. As a result of this incident, the availability and the reliability of a communication link get reduced. In order to establish the framework noted above, in the negative aspect, MIMO technique has been applied to the design of microwave link, where signal fading appears very high. MIMO technique use multiple antennas in both transmitter and receiver segment, and it is considered as a key to 5G communication technology to minimize the system power and enhance data transfer rate. MIMO technology relies on the antenna diversity technique comprising various antennas placed on the wireless base station. Now, the advent of fifth generation needs very high data rate, spectral effectiveness, and service of excellent quality, but the MIMO technique has no such capacity to meet the set requirements needed for 5G communication. To overcome these obstacles, the massive MIMO technique is the most significant one for improving power, spectral effectiveness, data transfer rate, and the feature of service. At present, the aim of the researchers and the developers is to exploit the high-density wireless infrastructure to heighten the efficacy of the wireless communication system by increasing the power of radio link. Now, I come to the concept of an 8 cross 8 MIMO. An 8 cross 8 MIMO comprises 8 transmitting antennas and 8 receiving antennas. Here, There are a, 8 symbols. Mm, First, uh, 8 time intervals: TS1, TS2, TS3, TS4, TS5, TS6, TS7, and TS8. In the first time interval, XS1 to XS8 symbols are transmitted. In the second time interval, XS9 to XS16 symbols are transmitted. This is the concept of an 8 cos n MIMO. Now I come to the point: design of different MIMO techniques. With the help of MATLAB, dialing system and dialing system generator, and 8 cross 8 MIMO has been devised in the same process by using the respective channel metric equation of 1 cross 1, 2 cross 2, 4 cross 4, 16 cross 16, 32 cross 32, 64 cross 64, 128 cross 128, and 256 cross 256 MIMO technique. Each of the MIMO technique can also be devised by using MATLAB and dialing system generator. The MIMO modules display as to how many times a block has been used to devise 1 cross 1 CISO to 256 cross 256 MIMO. The MIMO module has been classified into 3 categories: transmitter, channel, and receiver. Transmitter consists of signal generator, gateway in, and register block. Channel comprises add, sub, constant, and marked blocks. Receiver contains gateway out and scope blocks. Simulating blocks include signal generator and scope. System generator blocks contain gateway in, gateway out, add, sub, constant, and register block. Here, 1 cross 1 CISO 256 cross 256 new technique has been designed. Figure 1A shows that the block diagram of devising new system using simultaneous and system generator block for 1 cross 1 CISO. Figure 1B, it shows that 2 cross 2 MIMO. Figure 1C, it shows that 4 cross 4 MIMO. Figure 1D, it shows that 8 cross 8 MIMO. Figure 1E, it shows that 16 cross 16 MIMO technique. Figure 1F, it shows that 32 cross 32 MIMO. Figure 1G, it shows that 64 cross 64 cross MIMO. Figure 1H, it shows that 128 cross 128 cross MIMO. Figure 1I, it shows that 256 cross 256 MIMO. Next, I come to the point: hardware implementation of 8 cross 8 MIMO. And 8 cross 8 MIMO has been implemented by applying dialing in X78PG. The RTL symmetry model of an 8 cross 8 MIMO is shown in figure 2 in the slide. These are RTL symmetry of an 8 cross 8 MIMO. Next, I come to the point: proposed design of MIMO techniques using CMOS logic gate. In this figure 1A to 1I, we observe that with the increase of number of antennas, the resources are increased. So we have proposed a MIMO technique design using CMOS logic gate. The CMOS buffer, CMOS AND gate, and CMOS OR gate. We have used 3 types of gates: CMOS buffer, CMOS and CMOS OR, and we have calculated the number of CMOS transistors for both using the system generator and using the CMOS logic gates. We have computed the number of CMOS transistors. In this figure, S is the input radio signal, H is the channel matrix, HI is the inverse channel matrix. N denotes the additive white Gaussian noise, and Z signifies the estimated output signal. So this is the proposed design of MIMO technique using CMOS logic gates. Now I come to the point: optimization of MIMO using neural network. In this work, an optimization algorithm has been adopted by applying a neural network to obtain the best validation performance of the MIMO technique. Because an optimization algorithm is such a process which is performed by comprising different solutions until a suitable or satisfactory solution is available. A two-layer feed-forward neural network algorithm has been used in this paper. Three kinds of training algorithm, that is Levenberg macro-training algorithm, Bayesian regularization algorithm, and scale conjugate algorithm has been adopted in this paper. The hidden neurons we have used here 2, 6, and 10. Three types of hidden neurons are used here 2, 6, and 10. The simulation results are performed for the three training algorithms and for three types of hidden neurons 2, 6, and 10. And it is observed that the Bayesian regulation algorithm renders better result than the other two types of training algorithm, because the Bayesian regulation algorithm gives the minimum mean square error values. So we have chosen the Bayesian regulation algorithm. And in this graph, we observe that by using Bayesian regulation algorithm for 10 hidden neurons, the resource can be minimized by with the increase of number of antennas. So this is the of the Bayesian regulation algorithm for 10 hidden neurons. For 10 hidden neurons. Next, I come to the point conclusion. Conclusion. In the tropical areas, the major problem of wireless communication is signal fading that can be diminished by application of different diversity techniques, that is via frequency diversity, antenna diversity, etc. And the massive MIMO technique has been considered as an antenna diversity technique. It can be used to mitigate signal fading in the tropical areas. In order to overcome the drawback, an optimization algorithm has been adopted in this paper. It is now observed that the proposed design of MIMO technique applying in CMOS logic gates yields better result than that obtained from the design of massive MIMO using system generator. So therefore, it can be highly expected that the hardware implementation and application of optimized algorithm in the massive MIMO will be very helpful to the users in the tropical regions for minimizing signal fading. Now, these are the reference, and thank you, ScienceFather, and thank you once again the Global Awards of Artificial Intelligence and Robotics for giving me the such worldwide award. Thanks God, thanks Dr. from my supervisor, thanks everyone. Now I have concluded my speech.